What's up, people? Want to see something cool? Good. Here we have some compounds, some aqueous compounds. All right. And we are going to make some double replacement reaction predictions. Okay. So we're going to do a little Ed puzzle here. And you can see I have some compounds ready to actually show you this happening. Okay. So let's get to work. All right, before we can really do some double replacement reactions, we need to think about what is soluble and what is insoluble. Now, to do a double replacement reaction, what we're going to try to do is create something that's insoluble. Something that's insoluble you'll be able to see in the water and would be a precipitate. Let's check these compounds and let's see if they are soluble or insoluble. Sodium chloride, okay? And we're looking on the top of page 6 here. Look at this second bullet point right here. All chlorides are soluble, with the only exceptions being silver, lead, and mercury. So sodium chloride is soluble. And yes, you know salt dissolves in water. Silver chloride. Okay. We're looking again at our chlorides. Oh, look, chlorides are soluble except silver. So silver chloride is insoluble. See how this works? How about magnesium hydroxide? Ooh, over here. All hydroxides except for group 1 are insoluble. So magnesium is not in group 1. So yeah, this is insoluble. But again, let's look at lithium hydroxide. Lithium hydroxide. Lithium hydroxide, all hydroxides are insoluble except group 1, strontium, barium, and ammonium. Except group 1. Well, guess what? Lithium is a group 1 hydroxide. So this is going to be actually soluble. Now we've gotten that out of the way. Let's talk about mixing these two chemicals. We've got some sodium chloride and some lead nitrate. Now we're going to call this lead 1 nitrate because this bottle is incorrectly labeled. Sodium chloride and lead nitrate. Let's mix these two and see if they're going to make a precipitate. Okay, as we write this problem, we know these two are aqueous because we can literally see that it's in liquid form, right? So aqueous sodium chloride and aqueous lead nitrate. What's going to happen when we do a double replacement reaction? Who is sodium going to be with now on this side? Yep, it's going to be with the nitrate. See, we're just switching partners here. And who is lead going to be with now? Yep, lead's going to be with the chloride. We're going to call that lead 1, so that makes the equation right. Now, we're going to balance this, and guess what? It's 1, 1, 1, 1. Now, let's look at these two, our two new chemical compounds, and let's see if either one of them are insoluble. The first one we look at is sodium nitrate. Looking at the top of page 6, I want you to tell me if sodium nitrate is soluble or insoluble. Correct. It is soluble. And since it's soluble, we label it aqueous. Okay? So sodium nitrate, it says it right here. Sorry about the jiggling. All nitrates are soluble. All right? Now look at lead chloride real quick. Is that soluble or insoluble? Yep. Insoluble. So we're going to label that PPT for precipitate. Let's look at all chlorides are soluble except lead. And there's lead, so that one's actually insoluble. So we circle the precipitate. I always have my students circle the precipitate, circle it and label it. Let's actually see this happen. That'll be cool. I'm going to take the sodium chloride solution, the aqueous solution of sodium chloride. I'll pour it into the test tube here. All right. Then we're going to take the lead nitrate, and this is the equation, right? We're literally just doing this equation. I've got the sodium chloride right here. Then we're going to add the lead nitrate. We're going to make sodium nitrate, and you're going to see lead chloride appear in the water as a precipitate. Here's the lead nitrate. Here's the sodium chloride. And boom. Well, you can't see it as well there. See that white gel appearing? That is lead chloride. That's what you're seeing. That is a precipitate lead chloride. So you just saw this reaction happen. Good for you. Let's do another one. Okay, here's the next one we're going to try. It's sodium hydroxide aqueous. Here that is. NaOH. Plus magnesium sulfate, that's aqueous. Here that is. MgSO4, right? MgSO4. Okay, and now they're going to go through a double replacement reaction. Who is the sodium going to be with now? That's correct. It's going to be with the sulfate. What is the formula for sodium sulfate? Na2SO4. You have to write the formula correctly. Okay. And now who is magnesium going to be with? Burp. That's right. The OH. What is the formula for magnesium hydroxide? MgOH2. Right? Okay. Now we're going to look these up and we're going to see if either one of these are insoluble. First thing, we'll look at sodium sulfate. Okay? Sodium sulfate. All sulfates are soluble except calcium, strontium, barium, mercury, lead, 2, and silver. So this is sodium sulfate. It is soluble. Okay, good. Soluble. Now, since that's soluble, what am I going to put right here? AQ for aqueous. All right. Let's go magnesium hydroxide. Okay. Magnesium. All hydroxides are insoluble except group 1, strontium, barium, and ammonium. So guess what? Magnesium hydroxide is going to be insoluble. Insoluble. Boom. So this is going to be labeled how? What are we going to label right here? That's right, PPT. That's the precipitate, and we're going to circle it. Now we're going to balance this equation. I'll balance it for you. I've got 2 sodiums, 2. That gives us 2 hydroxides, and there's 2 right there, so that's good. Everybody else is happy. 2, 1, 1, 1. So let's actually do this, and let's make the precipitate magnesium hydroxide. Here we go. I'm going to take some sodium hydroxide. Oops, turn it where you can see it. I'm going to take some sodium hydroxide. I'm going to pour it into the test tube. So look, I'm literally just doing this equation. There's the sodium hydroxide right there. Next thing, I'm going to put in some magnesium sulfate. Here's magnesium sulfate right here. Some magnesium sulfate. Pour that in this test tube. Now, we're going to take these 2 and we're going to mix them together. Boom. See how it just turned white? That white chalky substance you're seeing is the what? You can see it over here better against the black background. That white chalky substance you're seeing is the magnesium hydroxide. Okay? And that's how you do double replacement reactions.